Hi students, welcome back to our channel. This is Kumar, and in today's video we are going to discuss about the rational numbers of class 8. So let us see what all topics that are to be covered in this chapter, rational numbers. So the topics are these are the topics that are to be covered in the first chapter, rational numbers. The topics are the definition of the rational numbers, and the second topic is properties of the rational numbers, and the third topic is a representation of rational numbers on a number line, and the fourth topic is finding rational numbers between two rational numbers. So they will give two rational numbers, they will ask to find the rational numbers, how many rational numbers they want, they will ask. And the fifth topic is a decimal representation of the given rational numbers. We have to represent the given rational numbers in the decimal form. And the last topic is we have to convert the decimal form to rational form. They will give one decimal number and we have to convert that into rational number. So let us discuss one by one and complete all these topics. And the first one is definition of rational numbers. For that, we will take a small number line for clear understanding. Here I am taking a number line where I am starting numbers from 1. I am starting numbers from 1 till infinity. I am taking number lines that is starting from 1, number 1. So we already know that the numbers which starts from 1 are natural numbers. So I am taking a diagrammatic representation on the left side. If you clearly observe, whatever the numbers I have taken, all those numbers are natural numbers. So I am taking a circle and denoted by capital N. This N denotes all the natural numbers. In the same number line, if I include 0 here, if I include 0 for the number, then all these numbers are called whole numbers. All these numbers are called whole numbers. So if you observe here, these natural numbers, if I take 0 for that number, then all those numbers are called whole numbers, and these whole numbers are represented by capital W. And if I take for the same number line, if I take negative natural numbers, if I take the whole numbers as well as negative natural numbers, then these set of numbers are called integers. These set of numbers are called integers. Integers are denoted by capital I or else capital Z. So integers are denoted by I or capital Z. If you observe clearly, whole numbers contains natural numbers and all integers contain whole numbers. Now for a clear understanding, we need to know what are rational numbers. So what are rational numbers means? The numbers which can be expressed in the form of P by Q. The numbers which can be expressed in the form of P by Q, where P comma Q belongs to integers. Where P comma Q, P and Q should be integers. And Q should not be equals to 0. If it is 0, then the number is undefined. We cannot divide with a 0 here. So the numbers which can be expressed in the form of P by Q, where P and Q should be integers, but Q should not be equals to 0, those kind of numbers are called rational numbers. numbers. That is the definition for rational numbers. So while we have discussed all these natural numbers, whole numbers and integers, you will get it out. But if you observe clearly, the natural numbers 1, 2, 3, all those can be expressed in the form of p by q. 1 can be written as 1 by 1, 2 can be written as 2 by 1, 3 can be written as 3 by 1. Even 0 can be written as whole numbers. If you take whole numbers, 0 can be taken as 0 by 1. If you take integers, minus 1 can be written as minus 1 by 1 and minus 2 can be written as minus 2 by 1. If you clearly observe, all these kind of numbers, that is natural numbers, whole numbers and integers, can be expressed in the form of p by q. So all these kind of numbers are called rational numbers. So for diagrammatic, what we can represent, all these belongs to rational numbers, and these rational numbers are denoted by capital Q. Why they are denoted by capital Q means these rational numbers are also called quotient numbers. They are also called quotient numbers. They are also called quotient numbers. They are also called as quotient numbers. When you divide two numbers here, what we are going to get? We are going to get a coefficient. So they are called quotient numbers, and which are denoted by capital Q. They are denoted by capital Q. This is the definition of rational numbers. This is the definition for rational numbers. And let us go for the next topic. What are the properties that are involved with the rational numbers? Let us see the properties of rational numbers. The first property is closure property. The first one is closure property. So what it says, what about the closure property and what it says regarding rational numbers. So what is closure property means, if you take a kind of numbers, suppose if I am taking a pair of numbers that belongs to rational numbers. So that means simply we can say a pair of rational numbers we are taking. So we are having mathematical operations. What are the mathematical operations we are having is plus, minus, into and division. These are the four mathematical operations that we are having: addition, subtraction, multiplication and division. So on taking the pair of rational numbers, on taking any binary calculation, you should get the same kind of number. That means you are taking two rational numbers on any calculation, either addition or subtraction or multiplication or division, you should get the same kind of number. That means a rational number. So then only we can say it satisfies the closure property. That is the closure property. If you take a kind of numbers on any binary calculation, you should get the same kind of number. That is called closure property. So if I take two numbers here, 2 and 3. So if I add these two numbers, that is 2 plus 3. So these two, I can say these two are rational numbers. So if I add these two rational numbers, I am getting a result 5, which is also a rational number. So the closure property for rational numbers satisfies. Is it clear now? Now similarly for closure property for subtraction. So the same two numbers I am going to take. I am subtracting those two numbers. 2 minus 3, the result is minus 1, which can also be expressed in the form of p by q. So this minus 1 is also a rational number, so it also satisfies for subtraction. That means the closure property is satisfying for addition and under subtraction. And now for multiplication. Suppose we take the same two numbers and and multiply these two numbers, 2 into 3, we will get a result 6, which is also a rational number which can be expressed in the form of p by q. So if you take these two, it is also satisfying for multiplication. If you take these two numbers for division, you are getting some result. It is a rational number 2 by 3. But when the denominator is 0, if the denominator is 0, then it is not a rational. So for that, another example I am going to take, that is 2 and 0. If I add these two numbers here, 2 plus 0, I will get a rational number. For addition, it is satisfying. If I subtract 2 minus 0, I am getting 2, which is also satisfying for subtraction. If I take 2 into 0, then I will get a result 0, which also satisfies for rational number. If I divide these two, then it is an undefined number. It is an undefined number. So it does not satisfy the closure property under division. For this value under division, it is not satisfying the closure property. So for division, we cannot say for all integers or for all numbers it will satisfy. So this is the first property for rational numbers. If you take a pair of rational numbers under any binary operation, your closure property is satisfying for addition and subtraction and multiplication, but it cannot satisfy for division. This is the first property under rational numbers. And what is the second property that we are going to discuss now? This is the second property. The second property is commutative property. Second property is commutative property. So under this commutative property, what it says actually, if you change the order of the numbers on any binary calculation, if you change the order of the numbers, the result will obtain will be same. Then we can say it is satisfying the commutative property. So let us see all four binary operations under commutative property for rational numbers. The first one, as we know that we are having four operations here, mathematical operations. Same, we will take an example here, 2 and 3. If I add these two numbers, I will get a result which is a rational. And if I say these two numbers as A and B, suppose I am assuming 2 as A and 3 as B. For commutative property, we have to change the order of the numbers. So if I take addition as the calculation part now, so this becomes A plus B. So we will get a result A plus B. If we interchange the order, so we will get B plus A. So commutative property says that if A plus B is equals to B plus A, it satisfies the commutative property under addition. So for this is only for addition. Similarly, we have to check on interchanging the order for subtraction, for multiplication and for division. Is that clear? So for the first example, for addition, if I take 2 plus 3 is equals to 5. If I interchange the order, then I will get 3 plus 2, which is also equals to 5. Then we can say under addition, the commutative property satisfies for rational numbers. And if I see for subtraction, for the same numbers 2 and 3, if I subtract these two, 2 minus 3, I will get a result minus 1. But whereas if I interchange the numbers, 3 minus 2 is the resulting 1, which is not equal to the obtained result here. So we are getting 2 minus 3 equal to minus 1, where 3 minus 2 is resulting 1. On interchanging the numbers, we are getting different answers. So it is not satisfying the rational numbers, not satisfying the commutative property under subtraction. Similarly, we will take for a multiplication here the same numbers. We will take for the multiplication 2 and 3. If I multiply these two numbers, 2 into 3 result 6. As well as if I interchange the numbers, 3 into 2 also results 6. So we are getting the same numbers. So this is also satisfying the commutative property under multiplication. So let us see for division. If I take same numbers 2 and 3, if I divide 2 with 3, I will get a result 2 by 3. And on interchanging, if I divide 3 with 2, I will get a different result. These two are not equal. So under division, the commutative won't satisfy for rational numbers. So this is the second property, that is commutative property. On interchanging the order of the numbers on any binary operation, the result should be same. So that is satisfying only under addition and under multiplication. For subtraction and division it won't satisfy. This is the second property, that is a commutative property under rational numbers. Let us see the third property. The third property is associative property. Associative property. So what this associative property deals with? So in this associative property, it says about it deals with the three numbers. It deals with the three numbers. So when you are applying mathematical operations, that is plus, minus, into, or division. So it deals with the three numbers. So you can take if I take operation plus here, we can add three numbers. Suppose if I take let the three numbers be A, B, C. For associative, it deals with the three numbers. So for under addition, we are writing the associative. That means first we need to add the first two numbers, and then the result is added to the third number. Or else the second and third number are added, and the result obtained is added to the first number. That means A plus B plus C, or A plus B plus C. So let us check these conditions for examples 2, 3 and 4. So if you take 2 plus 3 plus 4 or 2 plus 3 plus 4. Here 2 plus 3 is 5. 5 plus 4 is 9. Similarly, 3 plus 4 is 7. 7 plus 2 is 9. So in this case, in both the cases, we are getting the same result. So we can say rational numbers under associative property for addition, it satisfies the condition. It satisfies the associative property. Similarly, we will see for the subtraction part and multiplication part and division part. So under subtraction, if you observe here, first two numbers are subtracted, and then the result obtained is subtracted from third number, or the first number, the second and third numbers are subtracted, and these result is subtracted from the first number. So apply the same numbers for these 2 minus 3 minus 4, or 2 minus 3 minus 4. If you clearly observe here, 2 minus 3 is minus 1 and minus 4, which results minus 5. If you observe here, 2 minus 3 minus 4 is minus 2 minus of minus 1, then which results 2 plus 1, which is equals to 3. If you clearly observe, minus 5 and 3 are not the same. That means the rational numbers under associative property under subtraction, it won't satisfy the associative property. The same like if you take for multiplication, suppose the three numbers, that means A into B into C or A into B into C. If you observe for the same numbers, 2 into 3 into 4 or 2 into 3 into 4. 2 into 3 is 6, 6 into 4 is 24. Here 3 into 4 is 12, 12 into 2 is 24. The obtained results are same. So what we can conclude, we can say that for multiplication for rational numbers, the associative property satisfies. Similarly for division, if you take for division part, clearly observe A is divided with B divided with C. The obtained result is divided with C. Or A is divided with B divided with C. B divided C. For the same numbers, if I take here 2 divided by 3 divided by 4 or 2 divided by 3 divided by 4. Now if you calculate, you will see here 2 by 3 is divided with 4. So on simplification, 2 by 3 into 1 by 4, which is equals to 1 by 6. If you clearly observe here, 2 divided by 3 divided by 4. On simplification, 2 into 4 by 3, which is 8 by 3. When you observe the obtained results, 1 by 6 and 8 by 3, both are not equal. So under division or associative property, the rational numbers won't satisfy. And these are regarding the properties of rational numbers. Hope everyone understood these two topics. In this video, we are going to learn only the definition of rational numbers and the properties of those rational numbers. And there is another special case, that is distributivity of multiplication over addition. That is distributivity of multiplication over addition. That means there is a rational number A which is on multiplication or addition of other two rational numbers. That is A into B plus C, which can also be written as A into B plus A into C. A into B plus C can be written as A into B plus A into C. This is the special case, that is the distributivity of multiplication over addition. So these are the properties of rational numbers, and this is the part 1 video. In the part 2, we are going to discuss about the representation of rational numbers on the number line, and how to find the rational numbers between two given rational numbers, and how to convert the decimal form to rational form, or what are terminating and non-terminating decimals. Thank you for watching this video. Hope everyone understood the topic, and in the next video we will discuss the entire chapter with other topics which are left over. And thank you for watching. Please subscribe this channel. Thank you.